Good afternoon, good morning, everyone. Welcome to the OAI Open Accelerator Infrastructure track in the OCP Tech Week. I'll just go ahead to kick off the track for today. So me and Tianyi here gonna give an overview of the OAI project, and then later Tianyi will go through for the next 3 hours, and then we have a few talks, and then also we have a panel in the last to give it to everyone our overview and the details of about this project. For the overview side, our talk a little bit about the background and history about the OAI project. And currently in the OAI project, we actually have 5 work streams. And then I'll talk a little bit about the 5 work streams. And then later we also have some talks from these work streams. And then Tianyi will go through the contributions we had so far from this OAI group. And then later we have the workshops in details as well. So basically, back to March in 2019, Facebook, together with Microsoft and Baidu, we contributed the OAM OCP accelerator module spec into the community, and then at the same time we formed this OAI group. This is under OCP server project, and so basically this group focus on build the infrastructure for fast adapting upcoming products, which meets our OAM spec, right? The scope is basically we're gonna define physically and logically about these experts, including electrical, mechanical, thermal management, hardware security, and all these, including physical serviceability, right? All these around surrounded by the system design, basically building the infrastructure around the OEM. This is company list, whichever supports this OAI OEM group. And then actually this year, we have a couple new companies join our group as well. And then it just, we have not like updated the logo list. So go through this timeline for the OAI OEM back to end of 2017. As a lot of AI companies and join this field and then design these AI-related accelerators and solutions, right? We feel like we don't have enough resource, and also we don't want to build for every AI solutions or hardware system. So we came out with this idea, why don't we define the module spec? And then later we came out the OEM spec, 0.1 version, and then we started to engage with community. Soon, Microsoft and Baidu joined together and to form the spec further. And then March in 2019, we contributed this spec to the community, and then we formed the group. And then the rest of the 2019 year, right, we closely worked with Intel, AMD, Habana, NVIDIA, Xilinx, and Implant. In 2019, we actually released and opened total 6 kind of OEM compliant OEM module. And at the same time, we also contributed the OEM baseboard UBB spec to the community and updated to 1.0 middle of this year. And so recently, we've seen that as along with the work getting to the deeper and in depth, and then we split our OAI group work into 5 different work streams. So each of the work streams have a very dedicated scope and target and work related scope. So I So here I can go through high level, go through this workstream, and then later we have some related talks as well. First is the OAI system. Basically, this work group, we focus on define and maintain the current UBB and OEM spec, and then update and then keep updating based on the changes and the trend. And also working on like HIB, host interface board, chassis, like system firmware, right? Those are all related to the OEM-based system related development and standards. So that's the this workstream focus. Second one is the power-related workstream. So this workstream, we focus on power delivery of the OAI system, including the define the power requirement, the design spec, right? The recommend practice and the reference design. For example, also, if we see the some of the power block, such as a 54 volt to 12 volt, right? Such common power block we need to use in the system. It's also within the workstream scope that define common footprint for such power block. The third workstream is about thermal and cooling. So thermal cooling side, it's been a work that since the beginning when we define the spec itself. So this workstream focus on establish specs and framework, standardize the liquid cool related solution for OAI and also for the OEM from module level and also to the system level. Interchangeable OEM liquid cooling cold plate and also the OEM car. And we of course the target is a fully integrated liquid cool solution and modules into the server. The fourth workstream is about the high speed related. We know the future trends, right, such as 112K PAM4, PCIe Gen 5, Gen 6. So this workstream mainly focus on these high speed related signal integrity kind of like study and research, and also focus on the OAI system design with such high speed. So the work will directly impact our next generation OEM define, moving to higher speed, interconnect speed. The fifth workstream is about OEM tool. So this workstream is the only workstream related to the software so far. So we management of the module, right, in the system is a really important one when we deploy like into data center. So with the different OEMs, commonize these vendor utilities, right? Make a vendor agnostic utility for OEM related monitoring management, right? It's important. So this is OEM tool workstreams focus. Next, I'll move to Tianyi to like go through the contribution we have so far from this group. Tianyi, please.
Okay, can you hear me? So yeah. Hello. Thank you again for attending this session. I'm Tianyi Gao. I'm a staff engineer at the Baidu infrastructure team. I'm co-leading this OAI project with Whitney. Whitney presents you an overview of the project and some background information and introduction, so as well as 5 different work streams. And for the second half of this talk, I will be presenting you some high-level technical overview and updates, including the technical specifications. Those have been updated and contributed this year, and some of the collaborations and the progress within this project. If you go next one. As Winnie presented, OEM is the key module of this effort. So tremendous amount of work have been done on this module spec. So OEM is the AI accelerator. Be more specific, the OEM we are focusing on is the mezzanine connector-based AI accelerator. So OEM specification is the first spec published within this project. So this year we updated the spec and published the version 1.1. So the OEM spec includes the electrical, mechanical, thermal, structural, and the communication, interconnection, and design. So here, listing some examples. The specs defines the accelerator package, form factor, connector pin map, power and the thermal design at the different power envelopes, such as modules with 12 volt and 40 volts inputs, the module designed with air cooled and liquid cooled, mechanical structural for card implementation, as well as the interconnection topologies, including detailed port and the link configurations and the routing segments. So in different types of interconnect topologies, also includes the configurations of intra-module communication, host power connection, as well as expansion ports up to 8x6 links. So in version 1.1, one key updates is the system management, such as the management interface, firmware update, I/O calibration, and OEM security requirements are added to the spec. Next one. The first OEM spec version 0.85 was published early 2019. So in parallel, the project group was working with multiple vendors developing the OEM-based solutions. And at the same time, we are continuously verifying and updating the technical specs. Here are some good pictures showing some of the OEM-based AI accelerator which were developed and built by the several different vendors. I would also like to mention that there are also some other AI accelerator companies that are working on developing their AI solutions and products following and referring the OEM specs. Next one, please. The second important update is the UBB. The UBB stands for the Universal Baseboard. The baseboard is used for implementing and deploying different 8 OEM modules, OEMs, sorry, and providing communication, management, and interconnection. So this year we published and contributed UBB spec version 1.0. The spec 1.0 includes the I/O interface, electrical design, the electrical design such as the overall PCB board electrical design, thermal mechanical design, and such as similar as the OEM module, 40 volts and 12 volt power delivery, and air cooled and liquid cooled. Also on the electrical part, we also defined the communication such as host interface retimers and QDD-based scale-out design with 35 retimers. And also for the system management, if you go back to the previous page, also the system management such as I2C topology interface and so on are also included in this spec 1.0. Good, next one. Also, there are multiple system vendors participating in this work and helping contributing a great amount of efforts on the specs. So, and at the same time, they are developing OAI and UBB demo systems. Here are some pictures showing some of the existing systems developed by Inspur, Inventec, Hive, and ZT. And also, I would like to mention that this year we have new companies joining the group, Supermicro and Winwin. So the next step will be continuing the collaboration on the specs and also the system developments for both the UBB and the other major modules components in the OAI system. So I want to use the next slide to talk about the interconnect topologies. So as I mentioned, there are different designs and which are included in both the OEM and UBB specs. Here the slides include some of them, such as the 8-link based hypercube mesh, 8-link based quarter ring, fully connected, and also the fully connected combined with HCM. So the goal here is to provide high flexibilities on the OEM UBB to enable and promote different AI accelerator hardware and their corresponding topology requirements. So for the UBB spec, it includes different topologies to support different OEM, but the board level interface and the other parts are highly compatible. So next one. I mentioned that there is a combined topology which includes a fully connecting and a 6-port HCM. So design enables a single physical board to be able to use to support and deploy different topology-based OEM. You can see this further increase the UBB interoperability. So picture on the right-hand side, use as example, the corresponding PCB trace routing design is also included in the spec. So here, not only the design and the development efficiency we think can be increased on the system vendor side, but also with a high interoperability from the end user side, it may possible improve the deployment flexibilities. Next one. Okay, the workshop, yeah. So in our talk, we just give you a high-level overview on the project and the highlighted progresses. As Winnie mentioned, that the scope of the OAI project has expanded and further developed. And we also formed the 5 different work streams. So in this Tech Week OAI track, we presented a range of several talks, including technical presentations and a panel discussion. Our goal is to give a more detailed presentation on the technical update, progresses, and the future work, including a work stream plan and the scope. And also there is a panel discussion with a distinguished set of panelists and moderators to discuss the current, the future challenges and trends on the AI hardware and the system, and the value and the function the OEM and the OAI project can play and contribute. So next one. The final one, here are the links for the project wiki page where you can download the spec and get a project update and the project group mailing list. We hope there will be more and more partners and industry peers joining this project, and then we can work together to develop the AI accelerator, AI hardware specs and the standards, and also the ecosystem. And thank you again for your time, and enjoy the rest of the Tech Week and our workshop.